Well, ladies and gentlemen, moving on towards the next dynamic simulation for short and long-term grid planning. And we have a next speaker, Mr. Sudipta Saha, Practice Lead, Plant Engineering and Operations, Accenture. We
Good afternoon, everyone. I hope I'm visible and audible.
It is visible, and we apologize for the delay, sir.
No problem. I understand it happens sometimes. Everybody is working from home. And I think there is every possibility to kind of extend the hours when you are working from home. Yeah. No problem. I think, shall we get started?
Yes, sir. Are you ready?
Yes, I am.
Okay, you can share the screen.
Sure.
Thank you.
So this is the green button over here, right? Is it visible? Okay, I have to click the share button as well. Is it visible now?
Yes, it's visible.
I need to go to the slideshow mode, I guess, right?
Yes.
There is a window on the right hand side. How to minimize this? The one which is appearing on the right hand side. Okay, I think there is a minimize button.
Yeah. It's on full screen. It's on full screen.
Okay, fine. All right, so I think we can get started, right?
Yeah.
First of all, I want to thank Digital Discom for inviting me to talk in this session on a topic which is touching every life on earth today, right? With sustainability, being one of the major agenda globally, the whole utilities industry and Discom especially are under tremendous pressure to digitally transform themselves and in different areas, right? So one of them I'm going to talk about in next 20-25 minutes. So let's see what we are going to discuss. So first of all, it is not just during the pandemic that the whole utilities industry is under a huge pressure to digitally transform, as we said, right? Now, one of the major challenges, as I said, is how to really harness the energy balance when we are moving towards renewable energy. And this poses a huge challenge in the supply and demand balance. And so we'll discuss definitely about what is the solution for this. And the industry 4.0, cloud and AI, which are kind of driving this whole digital transformation. I'll talk about that, how we are leveraging these three together to solve this problem. We'll take a peek at the solution. I cannot demo it for compliance reason, but definitely I'll give a highlight of what we are doing here and how it is benefiting the T&D industry, right? And of course, if time permits, I'll take some questions on that. So let's talk about what is driving this transformation. So first of all, the decarbonization agenda, which is there with every country, right? So what does it mean actually, right? It means that every country is moving towards net zero carbon economy, which means that you cannot add any net carbon to the environment. So if you are using your traditional power generation sources, which adds a lot of carbon, then you should find out another way to compensate for that. So obvious, then the answer comes renewable solutions, right? But is it simple replacement of by the renewable? Answer is no, because then the renewables come with their obvious challenge of the variability in the supply, the seasonality, and also various environmental conditions which control the generation through the renewable sources, right? And then thirdly, the demand volatility is again another extremely challenging situation today. I mean, if you see definitely pandemic has contributed heavily towards the shift of the demand pattern, heavily towards, for example, the home sector. For example, most of the offices which used to be the heavy consumers today, that has shifted towards the household, right? The next part is that all the distributed energy sources, they are hooking up. I mean, they're just not consumers, they're prosumers. There are so many entities, they are continuously kind of generating the power, and that is creating a network balancing challenge. And the distributed asset, because when your assets are distributed, the obvious challenge comes in terms of tracking, monitoring, and utilizing them effectively. So basically what it demands, you have to, first of all, the variability that is there in the demand, you have to focus that. It easier said than done, because when you're talking about the demands patterns are changing, demands, the more consumers are getting at it, different kind of consumers are getting at, consumer behaviors are different. And the renewable sources, which is, I mean, it's a gift of the nature, all the renewable sources, and we can't predict the nature. So that is where, some aspect of statistics as well as nature science comes into picture, and how you kind of have a visibility of the assets in terms of their utilization, and also tracking the failure, etc. And lastly, last 2 points of power system analysis. Now, power system analysis is all whatever you do at the end of the day. You are hooking up new generator, the new distribution points are getting added. But then all that has to be analyzed in a transient manner, and you have to do it. It is much more than a simple supply-demand balancing. You have to do a network balancing at the end of the day. And then all these things comes under the domain of dynamic power system operations, which I'm going to talk now. So what's the solution? So this word dynamic simulation might be applied in different fields in different ways, right? But when it comes to power system, it means that you are continuously changing the constraints for which basically which are controlling the whole network balance. Which means you're adding generators, you're adding distribution points, you are adding more loads, and also this is all in a transient manner. That means it is not it's not fixed at a particular time. So basically, there are different scenarios, and within the different scenarios, you have different transient states at different point, right? So that poses the challenge of simulation and network balancing. So that is why we came up with this particular solution, and of course, the benefits are that it can definitely do much effective power scaling, which is the logistical side of the power balancing. And then because you are doing all this in system, you are avoiding your expensive setup to do different testing and other things. You definitely have a much better visibility and better decision making, right? I mean, especially when you're talking about a long-term planning. What is the situation going to happen after 5 or 10 years? What your generation scenario will look like? All that variability you are actually kind of foreseeing much ahead of time, and you can take necessary action based on that, right? Definitely, it helps in reliability because you are monitoring the assets. You can predict their failure, predict their uptime, all that you can do. And because you can plan effectively, you can bring all these things to operation much faster. Now, I'll talk a little bit about how we are getting into the solution, right? Now, there are 3 things here, right? So first is that what are the solution companies? When you're talking about this, what are the major solution companies I need to have, right? The first thing is we need to have a demand supply balance, right? Now, demand supply balance, as I said, it is not simply matching x is to y, x equal to y, right? It's much more than that, because when I talk about the network balances, you have power factor, you have the phase, and so many other things. You have all the LCR, as we call it, right? So all different kind of combinations possible. So because of which you have to balance the network balancing is a much more complicated than simply balancing the supply and demand side. I think, and then all this finally, and basically all the assets that you have in your transmission and distribution network, the assets have to be properly utilized. So everything has a specification, they come with a specified capacity, but then if you don't effectively utilize them, then you are not getting the maximum benefit out of it, right? And then since our goal is decarbonization, at the end of the day, we have to maximize. So these are the solution components. Now, what is the data we get, which we use for this, right? We use the historical demand data, right? Though the most recent data has the most relevance, but you can't ignore the past data, because many times certain things come in a variable way. But then you have to also understand there are a lot of factors which are changing the demand pattern. So you have to consider that. Same comes with when the environmental data is concerned, right? Definitely there are some changes happening in the environment. So you are getting the whole temperature, the greenhouse effect, so causing more carbon deposition and all of that. Now, we have to track that, because at the end of the day, when you're replacing the traditional generators by fossil fuel generators by your renewable sources, you have to keep a look, and you have to also geographically distribute them in such a way that you have a overall balance of the if you look at a heat map, it is basically distributed in such a way that you don't have a hotspot created at a particular location, right? And then the basically all the wind, solar, planet, all those things you need. Now, once you have the data, now this is where the modeling comes into picture. Now, we have all the modeling tools at our disposal, whether it is a AI model, whether it is a optimization engine, or whether it is a solver. We have all that at our disposal. But the most important thing is that what is the right thing to use. It's not about having some different model, but you have to use the right thing for right reason. So definitely we can use certain statistical models, ARIMA or VAR, for certain demand prediction and focus prediction. And then you have to also use them appropriately for your short, mid, and long-term forecasting. That is very important, right? Now, I will give a quick glimpse of the solution, right? So what are the functional components? What are the functional views of this? Now, obviously, this has three major, I would say, the solution engines in this system. One is forecasting, second is power systems, and third is geospatial. I think, as I said, the forecasting is all about understanding the variability of demand and supply, both sides. When it comes to power system, it is all about the network modeling and balancing. And then when it comes to geospatial, it's all about asset utilization. And when I say asset utilization, it is not about just the percentage utilization, but whether you are utilizing the asset with a minimum travel time, whether it is at the nearest location where it is needed, right? So basically, there is a workforce management which is involved with respect to geospatial asset management. So you have to manage the asset locations in such a way that you can actually mobilize your workforces in the most optimum way. Now, all of this finally has to be integrated to create a visualization or dashboard, right? Now, this dashboard provides you different kind of views. It provides you views. One is that so in a particular location, if you have a deeper look, if you want to see that what is the supply and demand pattern is varying. If you take a particular a city or town, you find out that how much generation is happening near to that point, and what is the distribution load at a particular node, right? And then at the same time, you can see that what is the source of renewable generation at that location, and how much is the transmission cost. What is it effectively can be utilized based on the location and things like that. Now, the third important element is the heat map, right? In the dashboard, the heat map provides a view of that. These are the points which need your attention. For example, there are certain cases, and when I say heat map, it is not just the temperature, it's also the carbon footprint, which means that how much carbon is getting deposited at that particular location, how much fossil fuel generation is happening. Now, you also may have other factors which is contributing to the carbon. For example, your vehicle emission, you can have, but then you also have a way to compensate that through your either adding more greenery or more water bodies, etc. So you actually have a holistic view of a particular location to see that what is the situation at a place and what are the things you can do. Now, all this finally give you an outcome which benefits all the uh, all the generators and T&D, but though it benefits everyone, I would say T&D are the most beneficiary because at the end of the day, they're the ones who has to address the power harnessing challenge, right? And if you see the outputs are getting used in power trading and scheduling, it can be used for power generation consumption pattern. Then it can be used for the network analysis or power system analysis, as we call it, in a transient manner. And then, of course, to get an geospatial view of the asset utilization and also the mobilization needed for any failure or any maintenance that is needed for that, right? And then, of course, it will also help you to create a future statement, whether it is a 5 years or 10-year statement, that how the whole thing will look. Because you can do all kind of scenarios to predict even the future, that how the generation and distribution scenario will look like, and whether that is how you can balance that, right? So that complete view will something you'll get from this. Now, I will probably not get into too much details of this, but lot of these are statistical and optimization analysis, but it also gives you a kind of high level view of what are the different kind of analysis is done. I cannot I don't have time to go deeper into this, but of course the whole analysis again centers around the three things that you see on the left hand side: focused, power system, and geospatial. And all these analysis finally gets integrated, right, through the solvers that we have built. There are two aspects which are very important in this: the machine learning algorithms for all kind of modeling, and the predictive analytics that you do for the availability of the assets. All right. Now, if I talk about the final outcome, right? So, what are the typical outcomes we can expect? So basically, since I cannot, for a compliance reason, I cannot give a demo, but if you see the right side of it, this gives off the solution, and you can if you see the dashboard, it gives a view of the distributed assets, the heat map, and the carbon footprint for a particular location, and also it gives that what are the energy efficient and deficient hotspots, right, where we have the more heat getting generated continuously, or where you can actually change this. And you can, since you can do a transient analysis, you can see that whether the hotspots are really getting hotter day by day, or there is a kind of decreasing trend. And then, most importantly, the load balancing that you need for the optimized asset utilization, that is also something you can do, right? There are a lot of things which on the left hand side comes as an outcome of this. I mean, these are different kind of, I would say, the services or offerings which can be provided based on this, depending on what the clients want. If it is a distribution client, they will be definitely like all the discounts. They will be interested to know that how they are going to harness the demand, the changing demand of a city or a state, and then how they can tap the available renewable powers, and what is the excess they have, what is the scheduled load balancing they have to do, what is the load shedding they have to do, all that analysis they can do from this. That's a whole kind of gamut of services that you can offer based on this, right? And finally, if any of this are needed for creating a long-term plan, for example, we have a target towards this much power generation through fossil fuel, and we have to cut down by this, then the whole scenario analysis can be done in a long-term basis, and it can tell you that how we can arrive at a solution in a gradual manner, because that kind of target cannot be achieved in a day, but it will give you a path that how to reach there. So with this, I think I come to the end of my presentation. I wanted to keep it concise so that, if there is any question I can address. If there is any particular area which is anybody is interested, I can definitely provide more details on that. There is an echo.
Gentlemen, there is a question. I would request you to please have a look at your chat box.
Oh, sure.
Yeah.
Is this a question? Yes. How will you? Okay. I think the question was, how will we go forward with modernization? Yeah. I think this is a loaded question. Modernization means can mean multiple things. So now, when you are talking about grid modernization, right? So which means that let's say you have more. One way of doing is, you are actually doing all the smart grid and other things that you do, or the microgrids that you are doing for the city planning and other things. Now, any kind of modernization that you have, the all ultimately can be translated to your distribution nodes, right? Now, all these things can be modeled for further simulation. So when you are adding any consumption point, or you are adding any particular pattern of consumption, it may be a variable in nature. It may be may have certain seasonal trend or whatever. It doesn't have to be a fixed value. So you are adding anything, you can definitely model that, and then you can definitely see that how your generation pattern has to change based on that, right? So what are the net gap you have, because the scenarios that you run, you'll give also certain options that you have option certain, or for example, you can go to 50% of renewable generation versus 30% of renewable, or you can hook up some D years into your source side. So all that options will be given at a particular point, which can be analyzed and taken in decision. So all the modernization aspects can be addressed by the simulation that it provides. Is there any other question?
Gentlemen, it's being sent to your chat box.
Yes. Okay. The question is, in SaaS, can utility company customize their business rule? If yes, how efficient is upgrade of this kind of solution? Yes, this is a very good question. Definitely. So basically, what happens is, when the business rules, now by this customization of business rule, what I mean is that the certain way of managing the demand and supply gap is configurable. For example, if you say that, okay, I have a certain price point for my power to be sold to the consumer, and and there is a threshold value I cannot reach at a particular point, then obviously you are putting a certain constraint in terms of that. So the whole simulation model can actually work based on that constraint and give you the solution which only caters to that particular threshold. So it will definitely not give you any solution which kind of exceeds that threshold value. So it could be a price point, or it could be any other scenario that you want to put as a constraint. So definitely the solution can handle that.
Well, sir, thank you so much for now. The remaining questions we will send you our email. Thank you.
Thank you so much. Thanks for attending.
Thank
Have
you
a
for
nice day. Bye.